Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems. And welcome everyone to the Distributed Data Show. I'm Patrick McFadin. With me today, Mr. Jeff Carpenter.
Thank you. Thank you very much.
Thank you very much. That was a good Elvis imitation. So, Jeff, we're going to change gears a little bit, not an interview today. We're going to talk amongst ourselves, a little private chat, just you and me and thousands of our closest friends, hopefully millions maybe.
Is this about my job performance?
Yeah, we're going to have that awkward conversation. No, we're going to talk about trends in data development, things that are happening, but way more important are these things that, as a developer who works with data, do I need to pay attention to these things? Because it is loud, right? And noisy.
Right. Yes. Sometimes I wish I could just go and work on my thing and code.
Just do it.
And not read everything that comes into my inbox or stop listening to podcasts. But guess what, people?
Oh, spend 10 minutes on Hacker News and you already feel irrelevant.
We got to keep educating ourselves.
Right. Exactly. And let's face it, this world is not changing. It has gone through different cycles. We're working with data development has gone through a lot of different cycles for sure. But in my opinion, there's hype and there's not.
Okay. Yeah. Are we going to call some winners and losers here?
Maybe just try to be informed about what you spend a lot of your time on. Because let's face it, how much time do you have during the day, right?
It's finite.
Finite. I believe it's 24 hours. Yeah, exactly, yes. All right, so 24 hours, you probably want to sleep in there. What are you going to learn, right?
We'll throw one out there for us.
All right, I'm going to just start off. Here's one on my list, and I hear this all the time. And I actually do a lot of talks on this too. Stream processing. And what's your first reaction when I say stream processing?
Oh, honestly? Wow, okay.
We're going to play word association.
So how is it different than messaging?
That's a great question, right? And I would say there are plenty of projects, vendors, people that are blending those two topics.
Yeah.
But getting a message from point A to point B is very different from taking a discrete or a batch of data in the stream and processing it in some way, applying some logic to it.
So you're talking about time windowing and...
Spark streaming is a good example of microbatch.
Microbatching, yeah.
Right. It takes a window, applies a slide to the window, and it processes things in those windows based on the data that's inside of it. So if it's a 1 second window, processes all that count, aggregation functions such as average, group by, any of those things that happen inside of that 1 second window in the stream, or discrete, which would be, that's like, for instance, Akka, for instance, does discrete. Storm does discrete. Flink does discrete. So there's a lot of different technologies that do discrete data, one piece of data.
Okay. Now what about, so in the messaging world, one of the problems that frequently comes up is this idea of message ordering.
Right. Okay. So
is that a problem?
Is it a problem? Well, sure. Because you want to make sure that the first thing in is the first thing out, because order does matter, and especially, and that's when you're talking about serialization versus linearization. Right. And the serializability of data, meaning 1, 2, 3, 4, not 1, 4, 3, 2. I got a joke for you.
Oh, no. I've already seen this cartoon. Yeah.
No, but it's these race conditions in your data is not okay. It's like knock knock, race condition. Who's there? Get it?
Yeah. Oh yeah.
Anyway, the race condition.
That's good.
Yeah, thanks. It's subtle. I'll give everyone a few seconds to think about it.
Pause the episode.
All right, time's up.
Okay, now we're back.
Yeah, you got it now. You're probably laughing. I get it. But race conditions in your data inside stream, sure. Especially whenever you have something like transactional financial data, which is
right. So do I use streaming for that?
Stream processing and data transactions, I would say probably not. And in cases where you're doing, maybe when you're trying to do some analytics on the data itself and not, say, processing people's actual money, but you want to see how things are going.
Perfect. Okay, right. So it's not part of that frontline transactional behavior. It's the analytics
Right.
that go beyond that after the fact.
Well, that's all right. So use case, always use case, right? And as you told me this earlier, it's just like nothing matters unless you have a decent use case. That's a pretty good guideline.
Words to live by.
Yeah, if you don't have a use case, then don't do it. But streaming has a lot of great use cases, from telemetry data, financial transactions, IoT, of course, probably lives and breathes on stream processing. More and more of it is becoming like retail is finding uses for stream processing because it's the immediacy of the data.
So I have to ingest a lot of data really, really fast.
Right. And I have to react to it. Probably the most important part of that is you can ingest and store a lot of data quickly. That's not a trick anymore.
Right.
We did that back in the day with Flume. Who remembers Flume? Oh yeah, I remember Flume. But what did we do? We just dump it in a file. Actually, I wrote the connector for the Cassandra one. That was my big move.
Okay, nice.
You're welcome. But it was a thing for just storing and then later processing. This is where you got the Lambda architecture, which was,
right.
You had some processing, but then you had the backend storage to store stuff, or just to store and process later. It needed it because maybe the volumes were so high, or you needed that larger aggregation. I think if you look at anything with stream processing, the first thing they say is Lambda's dead because you're moving faster.
Right.
Yeah. So, what do you think? Are you convinced?
Yeah, I think for the right use cases, it makes a lot of sense.
Okay. Well, I'm going to say that this, for any developer out there, it is definitely should be on your radar, definitely should be something you study and understand, at least from a use case perspective. It is a relevant technology for sure.
It's a tool in the toolbox.
Definitely. If you're working with data, be aware, and maybe even go out and do some tutorials, learn how to do some stream processing of your choice. There's plenty out there, but know it. What do you have?
I've been thinking a lot about machine learning, and specifically, again, what are the use cases for machine learning? The experience that I have and that I hear a lot of other developer types having is asking themselves this question, like, do I need to understand all of the math? There's a lot of math.
Yeah.
And so wouldn't it be nice if I didn't have to learn all that math? Or do I? What do I need to learn in order to set up a good model?
It is very clear that machine learning has come from some math person. Like TensorFlow has a whole different language.
Right.
It's not anything I'm familiar with. I'm not a hardcore vector math person. I know you're shocked by that, but it's true.
Right. No, I see that. So the things that I think are kind of no-brainer use cases are, the pattern recognition types of cases, especially where I'm able to train a machine learning model on a set of data and I'm beginning to identify anomalies and what doesn't fit that pattern. That's easy for machine learning. So I feel like any use cases that you have like that, if it's monitoring transactions for fraudulent activity, or if it's just looking at your log files to identify what's going wrong and being able to do preventative maintenance on things from an operations perspective, those are easy, no-brainer, yes, do those use cases. And then beyond that, I'm kind of watching to learn, like, where is this really going to fit?
Well, that's what I get this filter of this is so hypey, but when you start saying AI everything.
Right, let's AI all the things.
Yeah. Everything needs AI.
Yes, but right now, or what order do we attack the problem in? Where are the areas in which we apply this that are going to be the most successful?
Well, it's probably because the companies that we want to emulate that are successful, like an Amazon or Google, are using a lot of AI successfully.
That's right. So yes, not every engineer is building a self-driving car.
You're right.
Right. So, there's clear.
or am I?
Yeah. There's clear cases where, yes, we want, our computers to be able to learn and sort of simulate human behaviors and pick up on the things that we don't even know that we're rules that we couldn't consciously articulate, that these algorithms can pick up and begin to reproduce. So that's great. It's just that not every one of us is working on a use case where that type of knowledge is needed yet.
Well, and it's multifaceted. I think there are concepts inside of machine learning that are worthwhile, maybe, for everyone to know.
Okay.
Regression analysis.
Okay.
Regression analysis is a pretty basic. I think it's an evolution, especially when you're doing any kind of. If you're really proud of some crazy SQL you've written at some point, then maybe the next step for you is a regression analysis just on some clean data, because you can learn some things from that. That's a good one, I think.
Okay.
Yeah. Anything with clustering, classification, understanding how those work. I would be very surprised if that didn't somehow work its way into like an SQL style workload.
Okay.
Yeah.
So it sounds like from your perspective, it's a real thing that we need to be looking at.
Definitely relevant.
Relevant.
Yeah. So what do you see? Hype or not? If you're a data developer, what are you doing?
I think this is one of those areas to watch. I don't know if you run out and do all the tutorials yet. If you've downloaded TensorFlow and started playing with it, then great. But this isn't going to be a thing that's going to eat your job tomorrow.
It's true.
So start working on it.
Although, wasn't Terminator based on machine learning? Like all these AIs taking over the planet. Doomsday, they may just take you over. Just remember that. Yeah.
And that's the way I want to live, by fear.
Yeah. Well, just listen to Elon Musk. He's really on that game. Definitely.
Excellent. Okay, so why don't you throw another one at me, Patrick?
All right, I got one. This may be a little fringy we're starting to get into the fringe, right? NLP, natural language processing. Are you familiar with natural language processing?
Well, to a certain extent. Is this going to be the part where people need to turn the volume down because we're about to say the keyword and activate everyone's devices? So there's a certain set of terminology that we're going to try to talk around.
You're right. Yeah. No, was it C-core astronomy or something? No, you unlocked the AI. Okay, so natural language processing, it's one of those things that's kind of like what's old is new again. And it's based on a lot of new technology, of course, but it is trying to solve an old problem. And that is that humans, when we communicate with each other, completely stump computers. Computers that look at language and how humans communicate just don't get it. I mean, I'm sure you can understand. Have you ever done any kind of text recognition before?
No.
Okay. So that is a hard problem. And I think many of us will maybe laugh a little bit about Siri, and you talk to Siri.
Right.
Does Siri understand you?
No, it's just pattern matching, right?
Well, I mean, does it pick up your words?
Okay, yes.
Yeah, and The Rock, especially The Rock. The Rock knows, like, Siri, remind me to dominate the day.
Oh, right.
Yeah. Well, there's tons of research in this. Alexa and Google.
You did it.
I brought up the keyword?
Yes.
Oh, okay. All right. So Alexa, Google's got it way ahead of this. So natural language processing right now is definitely picking up. But what's the filter? How do we know if this is hype or not?
Well, so I feel like I hear a lot about this in the context of bots, customer service bots. Chat bots. Would you consider that a natural language processing kind of application? Sure. So that seems like a very hot area right now. Should we be doing everything with bots?
Yeah, that's a good one. Anytime, and there's also two different aspects in natural language processing: the typing of text and then speech recognition.
Right.
On top of that, and context and things like that. I was just at NLP Day in January, I think it was, And so I have a friend, Michelle Casbon. Hi, Michelle. She talks. This is where I get all my NLP knowledge from.
Okay.
So I'm going to tell you right now, I'm an NLP idiot. Michelle knows a lot. She works in this. She gets very excited about it. And it's because it really is the future in many ways. But then I have to ask myself, is this something that everybody's going to have to know how to do? Keyword.
Well, so yeah, thinking about this architecturally, like what is the interface?
Right.
So am I going to be I'm taking natural language and then am I trying to convert that into an API of some form? And if that, do I want to think about it as just an interface layer, yet another interface layer, or does it actually drive things in my application design? I don't know yet.
Right. Yeah, that is what I think about, is like, is this is just a person who's writing code for some application? Do you need to know how to do the NLP or just how to apply it? Is there a service out there or something like that?
Yeah, no, I think it will be as a service. I do think, I guess, amplifying what I said a minute ago, I think it does affect your interface design because it affects the interaction model, the states that you're working through within your application. But then tie it back to data for me. How does this relate to data development?
Well, a lot of data that we collect is in natural language. And I think this is going to so if you were to tie this into stream processing could be speech processing, and then eventually the context of that.
Right.
I don't know, maybe.
Okay, good. Okay, so we have a large database, say YouTube, of video content. We have lots of audio content that's maybe as yet unprocessed. That's a major mining problem.
Yeah, and you're looking far forward in the future. Yeah. I mean,
I do that.
We do. we as people collect data, as humans, we do that. And right now we're collecting text data, which is relevant, that's
right.
World Wide Web. But YouTube is how many years of video per second go into YouTube? All of that is speech. The transcripts of everything that we do, natural language processing pulls context out of. And these volumes of data that are out there are going to have relevance eventually. And I think that's just going to happen.
Right.
Yeah.
Huh. So yeah, there's an interesting tie there between the natural language processing as a potential way of getting more data out that then can be fed into our machine learning algorithms, et cetera. I'm beginning to see how this fits together.
So I'm gonna, based on your skepticism, I'll just say, yeah, it's useful. Know your use case, but then you probably want to wait for some sort of service to manage it for you. I think it's just knowing when to use it, not what it is. Okay. What do you got?
Okay, well, I would like to talk about graph databases. My feeling is that this has kind of turned the corner from hype to a real thing that we're starting to use all over the place now.
Yeah.
So I think, especially when we're talking about customer experience type of use cases, really, okay, so maybe getting a start in kind of like social networking world, very obvious interconnected graphs of people. But any of these things where we're talking about interrelationships between people, particularly strong use cases. So again, use cases like fraud detection. Maybe that's not your front line when you think of customer experience, but yeah, it is a customer experience use case because it affects if your customer's experiencing fraud, then that's generally not a great customer experience for them. So fraud detection, being able to navigate relationships between people, where they live, what places they're frequenting, what kinds of activities that they're engaged in, and being able to kind of pull out from those relationships things that don't quite fit or that fit known patterns of fraudulent activity. It's a great graph use case. And that's just one.
Well, you and I both do talks on graph now, I think because it is becoming more mainstream, or maybe it's because we're talking about it, it's becoming mainstream, huh? Maybe not that. All right. But if there's a world out there that needs more relationships and data, that's what graph does. It's a different data model to understand it. So back to the original premise is know your use case, right? I think that's much more of a problem I see where people get into trouble is when they think it's a one size fits all. Oh, graph everything. Everything is a graph, right?
Right. Okay. So yeah, you have some data that you're going to put. Maybe as data developers, we have some decisions to make, like what kind of data are we going to store in a graph versus a relational model, still applicable, versus Cassandra, tabular, NoSQL model, document style. You know, we have these choices to make. Do we have to make singular decisions when we're looking at our data? Like, okay, this data goes in the graph. Okay, this data goes in the relational tables. Or how do we think about that when we are looking at the data that we have to store and process, and what kind of data model are we going to interact with? Is it a choose one?
There's different ways to do it, right? If you're going to go with a pure graph model, knowing that data model ahead of time and understanding it is critical. But then you look at some of the technology in Spark right now, like graph frames allow you to do some very interesting things with not in a graph data model data.
But treat it as if it is.
It's finding the relationships inside of your data, which is really cool. That I've said that many times is, graph lets you find relationships.
Okay.
And graph frames inside of Spark allow you to work with somewhat different styles of those different models of data, which opens up that multi-model world in a different way. And analytics, for sure, not no LTP loads.
Okay, so good. Let's expand this conversation. It's my topic, so I can decide that
You
okay.
Expand it.
Right. We
let
just
it grow.
Expanded it out to multi-model. Is that also a hype or not hype thing? I'm going to put you on the spot here.
Hype or not hype, multi-model. Multi-model is table stakes.
Okay.
If you're working with a data product, any kind of data vendor like DataStax, multi-model should be just the common thing that you get out of it, and you should expect that. And now it's not always going to be the case, but it's just acknowledging the fact that our data lives in different forms. It has different life cycles, and the use cases are multi. And really, we used to use relational databases as almost a multi-model. But that one size fits all.
Yes, where we kind of force fit it. Put a graph API on top of a relational.
Right. It's the jack of all trades, master of none problem. Sure, it can do all that stuff, but then you start seeing cracks in where you're coloring outside the lines a little. You're like, oh, I'm over here now. I'm putting a graph data model on top of a relational database. Relational databases do one thing really well.
Right.
Map relationships into foreign keys and primary keys, and that does that really well. But when you start doing the multi-model on top of that, then you're in trouble.
Okay, so is that the holy grail then, to be able to store your data as if it's in any model, ingest it in any model, and read it back out in any other model with no perceptible performance degradation?
Yeah, I'd say that's a holy grail. It's a unicorn.
Yeah.
I don't know how much of it exists. You can probably get some Venn diagram overlap on some things. This model and this model work well together, and that's a multi-model that fits. But you're going to always have an outlier. Going from key value, which is like completely not normalized data,
right,
denormalized, to the most normalized data graph. Going from key value to graph, the gap is too big, and the technologies that are in between there are multifaceted. So saying that you're going to cover everything from one key, one value, all the way up to a highly connected, directed graph, no, I don't. I just can't see that as being one thing.
Okay.
But I'm probably going to get proved wrong now
Oh,
that
my
it's been
goodness,
put on official, like it's saved to the internet forever. And
Yeah, it's on a bunch of roadmaps somewhere.
exactly. They're going to play this at my funeral.
Half of the people listening to this podcast just crossed it off their roadmap, and then the other half like put 3 red stars next to it and went, "I'm going to prove Patrick wrong."
At Patrick McFadden, idiot. That's all I'm going to say. Multi-model's alive. Sad. That's what I'm going to hear.
Man, I feel like that multi-model topic. I'm sorry I threw that in there, but that could be a whole other episode. Maybe we can come back to that at some point in the future.
It's a term, and I've said this before. It's a great term because it's a description, but hyping multi-model is harder because now like I said, it's in 2017 when this has been recorded. It's table stakes for a lot of ways. Yeah.
I like the timestamp there. That was good.
Well, because, have you ever listened to a podcast and years later? And
Somebody
you're like,
who samples this in order to shame you is not going to, they're going to
Ruby on Rails is the future. I mean, I understand that you think that, C and C++ are great. I love Perl too, but Ruby is really the future.
Yeah.
Yeah. That's the podcast that everyone goes back to and goes, hee hee. But I just did that, didn't I? Yeah, but multi-model is important. I don't think it's not a thing. It's just the way that it's thrown out is kind of hypey now.
Okay.
Yeah. It's like saying Hadoop ready. Of course you run with Hadoop.
Right.
Who doesn't? Yeah. So on the hype curve, all of these things, it's the peak and then the trough of despair, which I love. Most of these are probably heading into the trough of despair.
Okay.
I think Graph for sure is heading into the trough of despair because we've gotten a maximum amount of hype.
Right.
Facebook made zillions of dollars off of Graph, social Graph. Everyone said that's great.
Right.
But now we're heading into this place where people don't know how to use it, and the trough of despair is going to be there.
Yeah. Is that what causes that? Is it lack of applying it wrong, not lack of developer education, like knowing how to use things?
In any of these technologies,
Not enough evangelists.
Yeah, well, there's early adopters, and that's where the evangelists are. Early adopters tend to feed the hype.
Yeah.
And you get this select group, maybe 20 people that know what they're doing with the technology, that tell everyone how awesome it is. Yeah. And then everyone's like, yay, that sounds amazing. And then they go and use it, and then they hit the trough because the trough is, they lied to me.
Right.
And then when you come out of it, usually there's a vendor involved, or it becomes a lot more realistic in its, okay, so maybe we don't apply graph technology to everything. And that's when you start coming out of trough. Why can I say that? Trough of despair.
Word.
There it is.
Yeah. So one final comment on this whole thing is that we definitely as developers need to be staying up, learning what the latest technologies are.
Late at night.
On your own time.
Right.
As you do that, there is going to be a temptation maybe for the solution seeking problem sort of syndrome. But in a lot of cases, I think maybe our instincts are better than we actually think. So as we're learning technology, as we get good at evaluating technology and seeing where it applies, more and more we're going to be right about what the use cases are about that. And I think it's definitely possible that in learning these new technologies, that helps to uncover use cases that you hadn't thought of before.
And you may not use the exact technology.
And that's right. But it just the act of learning that technology can open up some new ideas in your head about new things that are possible to do.
Right. And never stop learning.
Never stop.
I would hate for anyone to take this as stop learning, you know everything. Never stop learning. And even if you do take something that's a little hypey, that's okay. Just don't devote your life to it just yet.
Right.
But it's always fun to learn. All of these technologies I've dabbled in at least a little bit, and probably more than a little bit, just because I think they're interesting. Yeah, they're there for a reason. They're not because someone hyped it up. This isn't like a Kim Kardashian Snapchat. This is real. This is technology that people are using. It's not famous for being famous. Like you, Jeff. You're just famous for being famous.
I'm that guy. What was he on?
Yeah, he's great. I don't know who he is. Yeah, you were on. Weren't you on Full House? The show?
No.
Oh, okay, never mind.
That was not me in 16 candles
16 candles.
with the braces and the,
Oh, I thought it was. You get recognized for that dude all the time? Was it Anthony Michael Hall?
yeah.
You do?
Not anymore. My goodness.
Yeah, I was going to say, I was going to go walk around with you. We're in San Francisco. Let's go take a walk around and see if anyone recognizes it. Michael Anthony Hall.
No, if you did the yearbook photos side by side, there would be a lot. But today,
oh, gotcha.
Today, high school yearbook, yeah. Today, not so much. Yeah.
Okay, no, that's fine. All right, yeah, that's good. Well, maybe you're not that, but you do get recognized for being that guy. What were you in? All right, thanks, Jeff. That was enlightening. Way to end it. If you see Jeff out there, make sure you make him feel good and recognize him. Say, you're that guy from the Distributed Data Show, aren't you?
Yeah.
Yeah, that's me. Oh, great. All right, great. Thank you very much. And everyone, thank you. And hopefully this was helpful. If you have questions for us, don't forget, we have a Slack room in the DataStax Academy Slack. It's called Distributed Data Show. If you have some feedback, you want to tell me I'm an idiot, bring it. Let's talk about it. But let's
substantiate your case.
Yeah, bring evidence. But please join us for the conversation, and thank you. Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.